Welcome everybody, this video is going to be a comprehensive introduction to source code generators. So there's going to be an introduction, a bunch of timestamps. If you want to jump to the code section, check out the description so you can start taking a look at the code. But if you want the full experience, go ahead, make yourself a cup of tea, sit back, relax, fire up your favorite IDE and get ready. If you're wondering why do you need source code generation? Well, since the dawns of time when programmers were writing on punch cards, assembly language, eventually that gets repetitive. You start seeing repetitions in the constructs that you write. So you create other tools for yourself that will essentially generate that assembly code for you. So from assembly, we went to C, C++, a bunch of other languages, and Java, C#. All of those are essentially source code generators for the assembly. Here, all we're doing is we're just generating more C# code based on the C# code that you have already written. It really boils down to developers writing code that writes code to be more efficient at the work that they're doing. And that's pretty much it. So you end up with having to write little code for big optimized solutions, whether it be performance optimized or productivity optimized, or you can come up with some domain specific languages which will generate actual C# code for you based on some string that you have written. So that's the kind of thing that we're talking about here. It's useful. Will you use it in your day-to-day? Probably not. Do you want to learn a cool technique of how to write code that writes code? This is the place for you. So starting with the two projects, we have our source code generator. This is a simple library. This is not an executable, net6. We then have our application. This is an executable, so an empty console application, nothing in the program CS file. Let's talk about the example that we're going to be working on today. You have probably written a function and you wanted to share that function with other classes. And that has forced you to come up with some kind of inheritance hierarchy, like animal, dog, cat, vehicle, car, truck, that kind of thing. Really, what you wanted to do is you have a function and then you have similar properties between functions, and you just wanted to give that function there, you want to put that function there. You're a giver. You're a really kind person. You just want to give functions, but you have to create this hierarchy for whatever reason. Doesn't make sense, right? So today we're going to fix C#. Today we're going to, just write a function and just be able to give these functions left, right, and center. So let's go ahead into Program CS, and the first thing that you're going to do is you're going to create some plumbing. These are going to be markers, these are going to be attributes, interfaces, something that you're going to sprinkle around your code, which your source code generator will be able to pick up and then generate code on the back of that. So let's create a couple of markers. First thing that we're going to do is we're going to want to define a function. Somewhere it's going to exist somewhere, so let's go ahead and create an attribute that is going to be called define. So class define attribute and attribute. I'm going to copy attribute because I don't want to type it out again. And then we want to give something a function. So let's call it give attribute. Just like that. And this is our plumbing, our framework, whatever you want to call it. You don't need it to be in the app itself. If you want to have it as a library that you want to distribute, you generally have a separate process, and the resources, which we're gonna go over in a minute, describe how to package up your source code generator as a NuGet package. So if you want to go that far, you can. Let's go ahead and create our framework. We're gonna put the main plumbing in here just so it's a little bit out of the way, and we're gonna come back to the program CS. We're gonna create our function, so we'll have a public class. These are going to be functions, and we will create a public static class, and it's going to be static. We're not actually going to have access to the members of the class, although we can do it probably through a reflection, and maybe I'll write up an example which I'll skip over just so you can see that it's possible in the end. But let's just go ahead and start simple. So public static void, we're just going to have print, and here we will print hello world. I will leave that there as well just so my application compiles, but this is the function that we just go ahead and define. We will then have some kind of object which we want to give this to, or some kind of class if you want to be pedantic. So let's have car. This will have to be partial. We will create our public void. So we're gonna share the signature. So at the moment we'll make it partial. You can't have it be public and partial without being implemented, but we don't have the generator yet. I just want my code to compile, so for now it's not going to be public. We're then going to go ahead and give it a function of print. We don't have this parameter yet, so let's go ahead and I don't think I have the option to create the constructor here, so let's go to give, and we are going to have the name of the function that we want to give to this class. Now, we can give the implementation to a function, we can give a function to a class. There are many ways that you can, spin it and put things together, but this is generally the approach that we're taking here. It's not about the correct implementation at this point, it's more about how do you go about working with source code generators. So we have our example as if we would want to use it. Now we actually want to use it, or we want to create our source code generator in order to be able to use it. This is where we have resources.md with 3 links: official documentation, then documentation on GitHub, and Roslyn Quoter. We're going to be using all 3 of these websites. Links are in the description. And first of all, we're going to use the source generator's official documentation to set our project up. You're not going to set up a gazillion source code generators, I don't think, so I don't remember these options. I'm assuming you're not going to remember it either, so this is why we're taking this approach. We're just going to copy the dependencies that it needs. Go ahead to your function generator, place them over here, and this should give you everything you need. Now we're going to go a little bit further. This is the sample implementation for the generator. This is the thing that is going to be performing the work. So we will go ahead and add a function generator. We're going to place this over here. We're just going to grab the name and replace it here, delete the rest of the junk, and do the imports. Now that we have the thing that is meant to be generating a bunch of stuff, there will be an example here. I suggest you go through this just to see it work and maybe then come back here, but we're going to skip this and we're just going to go ahead and take our source code generator and plug it up to the app. What I'm going to do here is I'm just going to add a reference because I don't want to type out the path. So reference to function generator, open app.csproj, grab these 2 things that I will never remember, put them over here, and delete the item group again. I'll just clean this up a little bit, format, save, and the reference is now added. Congratulations, the project is now set up. Before we start writing our source code generator, let's talk about how to debug it, how to diagnose issues, because you're going to have those and you're going to be like, what is going on? I don't know what to do. We're going to talk about 3 techniques. All of them have their own advantages. Let's go ahead and get started. First thing that you are going to want to do, you're going to want to debug. Guess what? The source code generator runs when you build your application. So you never really press the run button on your function generator. You only really do it when you build. So a technique that you can apply if you want to debug it, let's go ahead. We'll say task delay. We want to delay this for 10 seconds. Put this number a little bit higher if your computer is slow, or if you are yourself a little bit slow, but 10 seconds is just about enough for me. So get results. You're not going to see it, but I'm going to place a breakpoint here and this line is going to go a little bit red. Here is the delay. I still have my program CS here. What I'm going to do is I'm going to open the terminal. I'm going to go ahead and make sure I will clean my project first, and then I will build it. The first time around it builds, this is where the build is going to take essentially 10 seconds because it's going to take 10 seconds to generate. I'm going to select this VBCS compiler that I'm going to attach to and give it maybe 1, 2, 3, 4, 5 seconds. There we go. We hit the breakpoint and now I can, do the debugging thing and actually inspect things. I would consider this a last resort. You don't want to be, fiddling about with this. If you .NET build and things are already built, it caches the build so you don't source code generators don't run again. So you will need to clean build. You will enter that sort of cycle, and it's not that snappy experience. For people that are more experienced, that don't tend to spend or waste their time on debugging, they will prefer logging. This is something that you can have as well. Maybe you can have a full-blown logger in here. I haven't found one. So what I tend to do is spit out things to file. So file, write all text. You will grab your source here. So we're gonna copy path, absolute path, place it over here. place an at the beginning. You can have a logger component, you know, whatever file. I'm just going to do a simple log.txt and some kind of diagnostics. Okay, let's go ahead and build this again. Now in my function generator, maybe, you know, this doesn't refresh straight away. I'm going to open a file folder and maybe this will show up later, but here's the log.txt and this should contain my diagnostics. So that's cool. There it is showing up there. So let's delete it. This is another way to write things out or a way to diagnose your application. The last way is kind of the quickest. So what you would do is you would just throw a new exception and this will show up as part of your build. So it would say things like hello for now. Let's build that. You will notice that nothing changed. So let's go ahead and clean first. We'll then .NET build again. We'll then see this warning, CSC, and the exception with hello. Now, this basically is kind of the equivalent of this log message, but instead of being able to output many things or like a whole trace, you are left with sort of just spitting out the last thing. So it's quick, but everything has its limitations. Debugging, you can inspect things. Here you can have multiple traces, but then you have to, you have this file that you're spitting out. And finally, quickest thing, but you only get the latest information. And also, new lines will not work. So hello QW, again, let's clean. Sometimes you need to clean, sometimes you don't need to clean. But yeah, let's build that. And then if you have a new line, that basically just doesn't work, okay? So make sure that you string replace new lines if you want to see what is happening. So we know how to diagnose issues and look around our source code generator if we want to. Let's go ahead and toss this exception out. There are 3 parts to the source code generator. You read, process, and then output the source code, and then your source code gets consumed by your application. Let's go ahead and read our code. Let's consume it. Let's see what it takes. So if we go to the context, we have to enter this compilation. So the current compilation context, what are we compiling? This is the thing. And here we will find, I think it is called syntax trees. So a bunch of syntax trees. For each one of these, we will have a tree. Not very descriptive, but there we go. I'm just going to go ahead and re-output these 2 files. I'll create my integer that will start at 0. And I will place it over here like that. And let's remove those curly braces. Finally, I will take this compilation syntax tree and I will convert it to a string. So get text, and this will have a toString. So to this file, I want to go ahead and spit out whatever this syntax tree is. Let's go ahead and rerun this. Let's see if I get any files here. I don't know if it's actually spat anything out. Looks like I have a couple of texts here. Coming back to writer, here we have our auto-generated imports. We have our program CS. We have our other file, which is our plumbing. And then some auto-generated code, which is fine. So we're basically this way inspecting source code from this app. The question that arises now is, this is essentially text. The code that we write is essentially text. You can write it in a Word document, in a Google document. It is just text. What do you process it with? Do you use regex? Do you convert it to JSON? XML, God forbid? I don't know, XML is fine. Maybe HTML? I don't know, right? So what do you convert it? How do you work with your C# code? Luckily for you, for each individual one of these, for example, for a class, you get a special class that represents a class and all of its members and all the attributes on the members and all the values in those attributes. There is a C# class or struct that represent all of these identifiers, braces, quotes, etc. And there is a way to inspect this information. There is an extension in Visual Studio that I will cut the video and I will do a little intermission, but in Writer, what you're going to do is you're going to find a plugin. So we're going to look for plugins and we want to find Rawsint. This plugin, if we fire it up, so Rawsint, will allow us to click on, let's find some source code. Let's say we want to take a look at car. What is a car? it is a class declaration with all of these tokens, with that name, with this method declaration, and this method has all these keywords, etc. Hopefully you get the picture. Your file is essentially a object tree that you can traverse. So no regex, no parsing. This information, all of this information here is essentially, if we come back to the function generator, you're going to see me fiddling about with this window quite a bit because I'll close it, I'll open it because it gets in the way. The compilation syntax tree, if we take a look at the get root is a syntax node, and this is where essentially the root of the file begins. This is where we are finding, all of these nodes that are appearing in Rosint. So let's have a little example. We're gonna get root, we're gonna go into program, we're again gonna go into the car, I'm gonna open Rosint, we're gonna navigate to it, and we're gonna take a look. Okay, this card, specifically this thing, is just an identifier token. However, it is enclosed in this class declaration. The type is class declaration syntax. It is all contained inside this compilation unit. Let's go ahead and from the root, we will try to find all the children. So child nodes. We're going to go ahead and filter them based on type. We're going to use of type and use class declaration syntax. We'll then toolist this or just use a for each loop like this. So class declaration syntax. And we're just going to do the same, but spit out class declaration syntaxes. So let's place this here. Let's take the class declaration syntax, place it over here, and use the same thing to get text and to string it. So this should spit out all class declarations to these files. I'm going to go ahead and delete them. I'm going to clean and rebuild the code. In one file, we have the car class. In another file, we have the functions class. So we have a class declaration in our program CS. What about these attributes? Are they not class declarations? Let's see what Rosint says about these. And it's also a class declaration and a class declaration syntax, which is enclosed in a file scoped namespace declaration. There is one more level that we have to jump over. So in our program CS, these are just contained in the compilation unit. So child nodes is not a deep search. It is a below level search. It's not like you don't walk the full length of the tree. Quick intermission for the people who still use Visual Studio. In order to use the syntax visualization tool that's available in Visual Studio, you have to modify your installation. You go to the individual components. When it loads up, there we go. We look for compiler, .NET Compiler Platform SDK, modify that. Once that's finished, launch your Visual Studio. And once you have your project open, you should be able to search for syntax visualizer. This will be the window that is now available to you. If I dock it over here, it can lag a little bit when you switch between files. As soon as it detects a change in the syntax, it will be brought up again, but basically wherever you place your caret, it automatically follows it. So the window layout and the information that you get shown in the syntax visualizer is essentially the same as in the Rosint plugin. So that's essentially an example of behavior. Fortunately, you don't need to write this logic where you're traversing all of the files and you're picking out certain files that you want to read from, or you just read all of them and you read for specific things. There's a little bit of an easier way. This is where we introduce the concept of a syntax receiver. Let's go ahead and create ourselves a class. This is going to be a public class main syntax receiver. And why main? This is going to be apparent in a second. So I syntax receiver, and let's make sure that we spell receiver correctly. We're going to implement this class, and I'm going to scroll down here a little bit. And do notice we're getting the syntax node here. The importance of this syntax node is that it's not going to be the root syntax node, it's going to be a bunch of syntax nodes. So you're going to be able to say, is this syntax node a attribute give? At this point, you have a good anchor point to work around. You're going to say, okay, if we are this attribute, that means we should be at a function. And now we can find all the relevant information to start generating code. So this is what we're going to be using. Let's go ahead and come back to our function generator. As I say that, I close it. So we're going to come back here. We are gonna define our main syntax receiver. Again, main, it's gonna be apparent why later, but here we have a context. We're gonna register for syntax notifications. And here we are going to supply a factory for our main syntax receiver. So that's what it's gonna spit out here. Now we have a little bit of global state from which we can pivot from. So if we go ahead and create index here, we take this bit right here, place it over here, and we say only and only if the syntax node is a class declaration syntax, that is when we want to go ahead and print it. So let's go ahead and place it over here. So syntax node, we want to replace this with index, and there we go. All of this code right here goes. Let's go ahead and delete the text files. Let's go ahead and clean and build. I'm going to come back to the application, and now we have all of our classes. So this is a bit of a more reliable way to scan through your application, and I think it's the de facto way. There are a bunch of ways that you can do this, but this way, you don't need to account for all types of files. You just need to make sure that people are using your implementation correctly. They're just putting attributes in correct places, and then stuff works. We have a way to read our code. Now we want to go ahead and output some code. Outputting is pretty much, we are going to construct a string, so this is going to be output. Let's go ahead and place it on a couple of lines, and you're essentially doing this. You're writing out C# code in strings. Examples tend to use string builders. We're not going to be using string builders. We're going to use something else. But let's go ahead and go through this example. So public class, and let's just call this class test. We don't want this interpolated. Let's put this on a new line. We're then going to have a public static void p for print, and this can have a console write line. Let's have a couple of more quotes, and then hello world. Let's indent this a little bit, and now we want to use this test class, but before we do that, we actually want to output it. So for this, we go to the context and we add source. We have to give it some kind of name, and the convention for this is hello.g and cs. G stands for generated. Hello is not the convention, it's just a thing, like the name of the file. So this is your name, and the rest is convention. We then give it the output, and this is it. So you generate some C# code, and then you spit it out. Let's go to program CS. Instead of this, let's use test. And if you haven't run your build yet, first the code is not going to work. I think Visual Studio doesn't correct it at all. Rather, once the code is actually generated, it will mark this code as usable. So let's go ahead and clean and build again. There we go. So built correctly. Let's go ahead and run this. There you can see the code is now usable, and we're seeing hello world. Now you'd expect this code to be automatically outputted into somewhere in your OBJ folder. That is not the case. This is again where we come back to the documentation. I will have to search for emit and emit compiler generated files. This is the option that we want to go ahead and put into app.csproj in the property group, and then mark it as true as well. Let's go ahead and close the app. This is now, if we run or build, it will actually create this generated folder where it should be spitting out your source code. This is the spat out code. So this is if you just use a string. Now, if you come back to the function generator, if we go ahead and try to use a string builder, just so you understand what happens when you use a string builder. So var sb new string builder. You're gonna have some logic. You're gonna, decide, should I place a function here? Should I place a function there? You're gonna have if statements, and you're gonna be slowly appending stuff to the string builder. So we're just gonna do the same. So we're gonna append a string. First, we're gonna append this, place it over there. That's good. We're then gonna take this perfectly legal C#, place it over here, and let's escape this. I was about to say escape. I think that's some kind of American pronunciation. or maybe not. Maybe it's English. I don't know anymore. We'll clear this output. We'll take this string builder and we will toString this. There we go. Very readable here. Maybe relatively readable, but nevertheless, that's what you get. So let's go ahead and rerun this and we'll take a look at the generated code again. Maybe I'll need to clean it and build it again. And in the end, this is what you're left with, right? So when you're generating a lot of code and you want to take a look at the thing that you've generated, String Builder, even though it is a performant thing, it slowly becomes very hard to look through this and be like, well, what am I doing here? So this is not the experience that you're looking for. The experience that you are looking for is essentially taking something like this, and I no longer need that folder, so taking something like this and going to the third link, which is Roslyn Quoter. And before we talk about the Roslyn Quoter, we're going to talk about the cookbook. It's just a resource with a bunch of recipes for the source code generator. People propose or show how to do specific things. Really small, tiny examples. One of those is how to publish source code generators as a NuGet package. Go ahead and check it out. I highly recommend it. Nevertheless, let's proceed to the Roslyn Quoter. The code that I copied, I'm going to paste over here, and here it is. I will place my spaces in here again, and I will change this to script file, and then I will get Roslyn API calls to generate this code, and this is what I get, okay? So all of these tokens, they all return objects, which again, those are kind of like those class declarations by which we can filter. These are just all factory functions for generating those tokens. So this is what you want to grab instead of, this is not my generator. Instead of this string builder, this is what you want to use. So this is going to be your source. You're going to have to import this namespace. So using static and C# syntax factory. Let's go to the top here and put this over here. Also import a bunch of other stuff, but this is essentially the sauce. You have normalized white space. You take the source, you place it over here, and then you use getText and encoding UTF-8. You don't need to use toString here. This is pretty much it. Let's go ahead and clean and build. So all of these tokens in the end will be turned into nicely formatted code, and all you have to do is place your logic, separate these out into their own templates, and provide essentially parameters to your functions. Those are gonna return different variants of tokens of different function methods, and it's gonna slowly construct your code that you want to generate. This is basically what you're aiming for. You can also mutate the code that you're reading, and this is what we're gonna do here as well. We're gonna do both solutions, but that is a way. Now that we know how to read and how to write, let's actually do the implementation. And this is where we find out why we have a main syntax receiver. You can only register one of these. However, when we scan our source code, we want to scan for two things. We want to scan for definitions, and we want to scan for places where we want to put our code. So I'm going to create two more syntax receivers. So let's actually copy this one here. I will wipe this. I'll call this definition aggregate. Hopefully I've spelled definition correctly. I don't need the index. I will copy this again. And then I will call this giveths aggregate. This is really, butchering the English language, but I think they kind of deserve it. Now that you have these two things, you go ahead and place it over here. So definition aggregate. Let's go ahead and place this as definitions. We will copy this. These will be giveths. We'll remove the setters, automatically initialize these, and just run our syntax node for these, because, well, they obey the same interface. So let's just go ahead and do that. And finally, when we run our source code generator, we are capable of taking this main syntax receiver. So receiver, we grab it from the context. So this will have a syntax receiver. This itself is an I syntax receiver. We want to go ahead and convert it to our main one, and that is not how you cast, but that is how you cast. And there we go. Once we have our receiver, we have our aggregated data. We are ready to look for many different things, smoosh them all together in our process, and then output them. Let's close the generated file. We will close the framework. We will take program, and we are going to start looking at this. Let's open up a Rosint. I want to go ahead and take a look and first register the definition. I'll put my caret on print. I will zoom in on this, and I can look for a method declaration or an attribute list that says define, or an attribute itself. So attribute syntax with an identifier name of define. So let's go ahead and do that. In our definition aggregate, if syntax node is attribute syntax, where the identifier, if that's not present, name. So you can do this, or you can do, big pattern matching or small pattern matching. It's whatever you prefer how to write your logic here. I am okay with this sort of pattern matching. So I'm going to come back here because I've already forgot what I looked at. I'm going to click on define. I'm going to navigate to it. I'm looking for an attribute with a name of define. Name will be an identifier name syntax. So name, can I find some text or identifier on it? I cannot. So name has to be that identifier name syntax, where you will have the identifier and the identifier will have the text, and this will equal define. Okay, if it is not this, let's go ahead and short circuit. We will return. This is going to be our attribute, which we can then start to work with. Again, coming back to program, we're again gonna zoom in on define. So we have this attribute, we then have the attribute list, and then we have the method declaration. The method declaration is the thing that has the block, which has the function body that we're after. So this block right here. A very useful function to write at this point is to get a parent of some type, which doesn't exist. So let's go ahead and write this out. Public static class. These are going to be syntax node extensions. So syntax node extensions, public static. This is going to be some type we're getting here. Get parent of type from this syntax node. I'm probably going to skip here because this logic is not too complicated. And this is what we end up with. We grab the parent, we enter a while loop, and we just loop until we get the desired parent. Nothing too complicated. I'm going to go ahead and send this into its own file and instantly forget about it. We're going to go to the attribute. We're going to go ahead and get parent. What parent are we getting? I know it's a method attribute, but again, in case you forget, zoom in on the define. We're going to go to attribute, attribute list, method declaration. This is what we're looking for. So method declaration syntax, grab the name, put it here, remove this type here, and this is a method. This method also has a name, and this name is print, and this is the identifier token on the method declaration. If we take a look at it, it is on the name or identifier. So right there, print. So on the var, I'll just call this key, or I can call it identifier, but there it is. Identifier, this is then going to have text. These are the two things. We are going to search for this key from this giveth attribute. So now that we have this information, we now want to bundle it up and save it. Let's create a public class, or actually a record will do a little bit better. This is a definition capture, or we can just call it capture because it's already a nested class. This will need a key and a method declaration syntax right there. So method. And now we'll create a prop. This is going to be a list of capture. These are going to be captures. This is a new list that we don't want to amend. And to this list, we finally want to go ahead and add all the things that we have defined. Key and method. At this point, you can pause, print these out to a file or throw an exception to see if you're getting the correct thing that you're expecting. I'm just going to go ahead and move forward and go through the giveth attribute. Same thing, I'm going to look for an attribute syntax. This time, if I go into program and I look at give, give will have give as the name that I'm looking for, right? So give right there. And then we are looking for the target implementation. So we're going to have attribute argument list. In the attribute argument, we're going to have a string literal expression, which is going to basically end up at print. And this is what I'm looking for. I'm looking for this print value, this syntax token, which in the literal expression is going to be in the token parameter. So coming back here, we're going to go try to follow this. So attribute, we're going to have an argument list. Argument list is going to have arguments. I'm only expecting a single one, so let's go ahead and use a single just in case we're going to throw an exception. So for this, we want to go ahead and do we want to grab a token? I'm not sure. I have forgotten now. So let's take a look at this again. We in the argument list, attribute arguments, we are getting our individual argument, which in this case is a literal expression syntax. So let's cast it as a literal expression syntax. So LES, or I'm just going to go ahead and wrap it like this. Here I can extract the token, and the token should have value or text, or value text is the specific thing that I'm looking for. This is going to be the target implementation. It's complaining that I probably cannot attribute argument syntax. I will probably, yeah, so I need to extract the expression. I need to cast that to a literal expression syntax. Once we know the thing that we want to grab, we want to go ahead and, well, make sure that we can actually reconstruct the rest of this class. We want to know that we're actually overriding this do function, we're actually overriding this car class, and we want to replicate of it as much as possible. So again, we're going to use that get parent method to go from this giveth attribute. So from the give attribute, we're going to go up to the method declaration and then up to the class declaration. So let's go ahead and get our method, which is going to be from the attribute get parent method declaration syntax, and we're going to do the same for the class declaration. Again, we're going to have our capture. Let's take this record, place it over here. This will be the target implementation. We will still have the method, and then we're going to have the class declaration syntax. We will then take this list, place this over here, again a list of captures, and in the end we want to add our capture here. So new, let's add target method and class. Class declaration syntax, I've not actually got the parent for the class, but I got that now. So we have a bunch of captures, we have a bunch of giveths, and by captures here I mean definitions and giveths. We now want to intertwine the information that we have here and generate the appropriate code from the context that we already grabbed the receiver. And to actually free up space, what I'm going to do is I'm going to move the rest of the classes out of this file. So, and yeah, add that to source code. But yeah, if you want to see what is happening here, these are the files. Maybe I'll get rid of the text files, but we can go ahead and close that. At this point, we are interested in the process, and again, I'm going to remind you, feel free to stop, output things to file, just kind of start building up that image in your head of where you are in the code. I would suggest not to debug, but once you're getting stuff in your receiver, try to throw it as an exception, just see what you're looking for. And let's actually go through this, because there is a very useful thing you can do when you're throwing things. So let's go ahead and throw a new exception from the receiver, and looks like I have just lost all IntelliSense and Writer, or actually it came back. So we have a bunch of definitions. We're going to go ahead and grab the first capture, and we are going to grab the method. We're going to get the text of the method, and the method itself is going to have a bunch of new lines. So let's first toString this, and there's actually a better way to do this. We're actually going to full string this, so instead of getting text. And again, let me just close that. I'll save that. Let's go ahead and clean this, and then we'll rebuild. So this error doesn't matter. The important thing is this method that we were about to print, we can only see the attribute because it's multiple lines. So what you want to do is you want to replace line endings. I don't know where this convenient, very convenient method comes from, but just replace it with empty strings, right? Rebuild this again, and the exception that you will see now is the full method that you're looking for. So this is the convenient thing with the exception. So something is failing, just throw the exception, show where you are and what you're looking at. But at this point, I'm quite confident I am capturing my desired definition. So the logic is pretty much for all the giveths that I'm doing, go find the relevant definition and place it where I am doing the giveth, right? So receiver definition, let's take a look at all of the captures, and for each definition, so I'm just gonna call it def, I want to go into the receiver and I want to for all the giveths, right? I want to then go into all of the definition captures and I want to find first or default where the key equals the definition target implementation. Okay, this is going to be the giveth, and this is the definition. Now let's make sure that we replace this def there, and there we go. So we've extracted our definition. I now want to take the original class, so where I'm doing the giveth, I can throw new exception. So in giveth, I have the class where again I can to full string and replace line endings, semicolon on the end. Actually take a look at the full code and look at this thing as I'm working with it, so I don't have to keep reattaching the debugger, but you know, as you get used to this more and more, you don't really need to execute this that often. And the cool thing with these tokens, these things that represent the classes and everything like that, they have methods such as with. You can take the current thing that you're looking at and replace specific parts in it. So for example, I can take this class that I'm giving things to, and I'll just say, I want to replace your members. And at the moment, I'm only replacing it with one member. So let's go ahead and provide a new syntax list. So with members accepts a syntax list of member declaration syntaxes. And then for the member declaration syntax, that is where I want to do a little bit of a construction, because, you know, I'm changing the name, I'm removing the attribute, I'm doing a lot of things there, and I just want to select specific things. For the car, I'm just going to say, I want to replace this thing. And that is what I'm gonna do. So let's place the semicolon there. I'm gonna say that this is the end output that I want to do, and place this output over here. I'm gonna rerun the build, and this is gonna give me a car class, but without any members. I can then create a private method declaration syntax, create giveth method, and then I can pass some information here that I can use to generate this method declaration syntax. So let's come back to the Roslyn quoter and see what this looks like. If we place our cursor here, we will see up to the parenthesis that this is going to. So let's copy about yay much, place this over here, and return. This is a singleton list of member declaration syntax, so we don't actually need this much. We just need the method declaration and then remove a couple of parentheses on the end, just like that. And now replace the appropriate things. So the name of this function is going to come from the class that we are doing the giveth thing to. So let's go ahead and supply the method declaration syntax, which is the giveth method. The identifier for the function is going to come from there. So we don't actually need this factory function for the identifier. We just grab the identifier from here. We then have the return type here. Hopefully we can go to the giveth method and grab the return type and place it over there. So we end up with something like this. We then have a modifiers or token list. So again, we go to the giveth method and we're going to take the modifiers. We then have the implementation, which is the expression body in this case. This is where we're skipping all the attributes and stuff like that. However, we're not doing an arrow expression. What we're doing is just a body. So again, if we come back to program, we take a look at this, and this is an expression statement and a block. So if we come back to here, and instead of an arrow, we type out just an expression block. So let's put this to a new line, get a generation of this. We will see with body and block. So coming back to here, function generator, again, the body can come from the definition. So this will be another method declaration, and this will be the definition. We will say with body, we will go to definition, and we'll grab the body from here. We will delete the with expression, and then with semicolon, maybe we need it, maybe we don't. Let's go ahead, keep it there. If we have one too many semicolons, we can take it out. With members, create giveth method. Let's run this. We're gonna giveth. I'm struggling to talk now. We want to go ahead and grab this method and then pass it this method. And this looks okay to me. Let's go ahead and see what this output will look like. Let's build. And there we go. We're generating a public class car with a partial void do. We just need to spit it out to a correct file. So let's do that. Context, add source. From here, let's supply from the giveth class. We can grab the identifier and text, CS, and then we have our output. Let's get rid of the exception. We want to do the same thing where we normalize a white space so it's actually all nice and pretty. We will then take the output. Here we will get text and we'll do encoding, UTF-8, and this should do the job. So coming back to program CS, let's remove this. We will make this class public. It should copy out all the tokens. Let's clean everything and we will rebuild. It's complaining about no main function, but that's just because I don't have the code there. So let's go ahead and create our new car. And then on the car, we're going to call the do function. Now let's go ahead and run our application. Looks like we have a error in here for our generated car. Let's just get rid of the hello. And we have one too many semicolons. So we're going to come back to function generator. We're going to remove this code right here. And we're going to clean and run again. And there we go. Hello world. So now we can define, as many classes as we want. Give them the functions that we want, and in the end just go ahead and start consuming these functions. There we go. Pure function reusability, no abstract classes, no interfaces, none of that useless crap. Quick intermission. In the beginning of the video, I said I will show an example with not having a static function. Here's an example of calculating a full name. We're using reflection to get the first name and last name properties of the object, and we're able to create a person with first name, last name, give the person this function, and then construct this person, and the result is pretty much what you'd expect. You get the full name printed to the console. Hopefully you get the picture. This will be it for this video. Hopefully you've enjoyed it. Again, all the links are in the description. If you have any questions, make sure to ask them in the comment section. There will probably be a follow-up video where I'll explain some additional concepts once I understand them a little bit better. Do tell me what you think. Don't forget to like, subscribe. If you would like to get your hands on the source code, support me on Patreon. For all of the patrons that are already supporting me, big thank you. You do help me make these videos. Goodbye everybody. Have a good day.